Good morning, everyone.
Good morning, sir.
Morning. So start in a minute or so, and let others also join. Okay, let's wait for 2 minutes. Meanwhile, I'll just import the necessary libraries. Yeah, there are two people only. Yeah, let's wait till say 9 or 5. Let
Good morning,
me.
Stanton.
Good morning. So maybe there are 3 people now. Okay, there are 3 people. Let's wait for maybe 2 more minutes. You guys can tell me, okay, which data set to take. So maybe I'll go to this repository. What has happened to this? This doesn't work. Just give me a moment, please. Let's pick a simple data set. Let me see which is a simple one. I mean, not so big. Okay, let's use this. Doesn't look like very big. Do you see the file anywhere? Here it is. So here is the dataset link that you can download as well. Closed it. Anyway, so
Control Shift P will help.
I didn't get you.
Control Shift P.
Control Shift P. This is like the last.
Yeah, last tab.
No, this was the last tab in Chrome. I don't think that supports Control Shift P. In Firefox, maybe it does, but not in your in Chrome. Okay, just a second. I don't know what's the problem with this website doesn't support maybe Firefox. Okay. Anyways, I'll upload this data set to your folder. That's fine. Right. Okay, this is the data that we have. So okay, so it's essentially related to clustering, by the way. So given some features, okay, we have to probably cluster these people. Now the question is, okay, do you think any categorical features? Okay, let's try to analyze if there are any categorical features or not. Okay, let me just look at info. Everything looks real only. So if you look at age, okay, anemia seems to be yes or no. It's categorical, but it's kind of between 0 and 1 only. Then this is some value for maybe a compound. This is diabetes is yes or no. This seems to be a real value again. High blood pressure, yes or no. Platelets count. This is some again compound. Serum measurements. Okay, sex is a categorical variable, but it's just 0 or 1. So binary variables are okay. Okay, let's make a list of our real features. Okay. So if you make a list of real features, let's make a list of them. So it seems to be age, right? And what else? So there is age. Then you have this. Okay. Because I'll be processing them, so it's important I keep them in the same list. Okay, then you have ejection fraction. Instead, let me call them as the numeric features. Okay, then we have platelets count. And the others are what? This serum sodium, serum creatinine. Anything else? Right, that's it, right? And then you have time. Time seems like I don't know what time is. Is it the hour or I don't know? Let me just see. What type of values are here? What do you think time is? It goes up to the minimum is 4, maximum is any guesses? What do you think time will be here for this data set? It goes up to 285. Is it like this doesn't seem to be in minutes, this doesn't seem to be in hours. Any guesses?
Maybe days.
No idea.
Maybe.
Days.
It could be days, like 0 to 366, any number between that. Could be, but okay, I'm also going to assume it like it's a real feature, okay, numeric
Don't you
feature.
have description of this data set here in whatever?
Let me try to see. Let me try to see. Just a second. Let's see. So here it is. It's days only. You're right. It's follow-up period days. So after how many days they followed up? So you have 13 clinical features. Okay, and okay, some features are Boolean. Essentially, they are categorical. Okay, and okay, if the patient died during the follow-up period, so then you have yes or no again. All right. And okay, makes sense. It's a days only, so it's a numeric feature. So it's time here. Okay, so these are the numeric features. Okay, now that I've opened it up, I'll just save it for you guys. So this is where you can download the dataset from. I just chose a random dataset, okay. All right, let's see if it has any null values. It doesn't seem like it. Okay, so no null values. Anything else that you want me to do apart from, say, like normalizing the features? Anything else that comes to mind? Yes, people. What name did I give? Did I miss? Oh, after platelets, there is a new line. Doesn't seem to be a new line. Okay, just a second. Maybe in the data set there's a problem. Have I misspelled anything? It says none of the index are in the. I called it DF only, right? Yeah. And these are my numeric features. Okay, I'll try to get it using the indexes. Got it. Okay, makes sense. Okay, I got all my numeric features. I'm going to normalize it. So let's just normalize it. Or rather, what I'll do is I'll do it like this. Okay, this is easy to do. Okay. Just to show you. Do you remember the formula for normalization? Yes, people. Do you remember the formula for normalization? You do, right?
Yes.
So I'm going to subtract the minimum from every entry. Okay. And then I'm going to divide by the maximum minus minimum. Okay.
Here we can't use directly min-max scalar.
You can use it. You can use it. Do you want me to do that? I can do that also. But then I have to pass these values. Okay. You can use this. There is no harm in it. Do you want me to show how to do that?
Yes.
Okay. So, okay, there's a problem here. Maybe in some cases, oh, it has assigned all of those values to zeros. Oh, okay, got it. Maybe I need this dot values thingy. Just a sec. I said max minus max. Why are these values nans? Just a second, okay, just a second. I'll show you using both ways, okay? So it's no harm in that. Oh, there's a problem here itself. Let's see. It doesn't do it like this. I have to do it per feature. Okay, I have to do it per feature. You cannot do it in one single shot. Or maybe, so I'll show you in both ways, okay, how you can do this. So these are the numeric features, right? I thought maybe there is one single way to do it. But when you assign the data frame, right, it doesn't work for combined together. So this is like this. So you can say for J and say numeric features. These are your numeric features. Okay, so it is, these are your numeric features. Okay, I'll just show you again. I'll show you using both. Okay, so the very first time it will be age. So what you're doing is you are saying that, okay, just to show you, this is your DF of age. Okay, you're subtracting the minimum. Okay, you're subtracting the minimum from every entry. As soon as you subtract the minimum, what happens? Just a second, let me see. These are values. This is strange.
Can we try to store the minimum in some variable and then?
Yeah, I'll also do that. Just a second. This is a little strange for me. Okay, just a second. Oh, I think I changed the original data frame, right? That could be a problem. Oh, once again, I need to reread it. Okay, so I assigned it, right? So that was a problem there. I assigned it again. So I don't think there will be a problem now. Okay, so these are the values. Then you can do this. Okay, DF of age dot minimum. Okay, you got the minimum, and then you divide this by. I mean, this should have worked in the first place. Maybe I made a blunder. It should have worked for the whole data frame also. I don't know why it's not working, but anyways. Okay, so you can do it like this. So what you can do is this df of this df dot LOC of this j. Okay, and you're going to assign it to this. So wherever you see this age, just make it j. Does it make sense?
If we give LOC first.
I'll do the LOC thing as well. It doesn't. It won't matter though. It won't matter though. I mean, you can directly do it like this. Okay. In LOC, it will fetch the row number, so this would be right. Okay. Does it make sense?
Yes.
Okay. So this is all right. Okay, so we have done it, and this is your data frame now. Do you see that all values have been normalized? Okay, and let me show you now how you will normalize all the values using the function. So let's say this is your data frame. I can simply say df of numeric features. Okay, this is your data frame. I want to normalize this. Shall I take the original one? Or is this fine? Just to show you. Because it will not change anything. Okay, it will not change anything. I'll just show you this. Okay. So maybe say what I'll do is this. Let's call the min-max scaler. So you go to sklearn, go to pre-processing. You import your min-max scaler. I don't know, somehow I always misspell this. Import the min-max scaler. You don't have to give any range because the default range is 0 to 1. But if you want to specify, you can do that as well. So you can say, I want to do it between 0 to 1. Okay. And then you can simply fit, since I'm doing it for the entire data set, I'm directly fitting and transforming. So you can just pass this and it will get you the transformed values. Okay. Okay. It will give you this transformed values. It will show you all the values being transformed. Okay. Does that make sense? So if you look at the first value in your age, it would be this. Can you see the first value in your age? Does that make
Yes.
sense? Okay. So you can now assign this back to your data frame. All right. If you want it to be done in using this function. Okay, I'll just comment it. This is fine. Okay, let's just keep this. So we have normalized our data between 0 to 1. Now we are ready to do clustering on it. Is there anything that you are missing? No, right? Okay, looks all right to me. Okay, so let's do clustering on it. So we have done k-means yesterday. Do you want me to repeat k-means for this data set? Or shall I directly implement dbScan on it? What do you recommend? Shall I repeat k-means on this entire data set? See, obviously we cannot visualize it because there are so many features. If you look at it, how many features do we have? We have 13 features. So we cannot, plot it. Okay. So, all right, let's go with dbScan directly then. Go to sklearn, go to cluster, import dbScan. Okay, let's call this dbScan, maybe say SM3db. So in dbScan, there are some parameters, hyperparameters. We will see that in just a bit. I'm using the default ones. Before I go to dbScan, can I take some other data set and show you the limitations of k-means? I don't think I covered it yesterday. Shall we do the limitations of k-means first? And so that you understand, okay, k-means will not work well on, say, non-convex data. I don't think we covered it yesterday, right?
Yes.
Okay. So I'm going to show you a small data set that you can visualize. Okay. We'll use this data frame again, okay, just in a bit. So this will give us non-convex overlapping clusters. So I'm going to select, say, 100 samples. Okay, this is fine. I'm only going to need the features, not the outputs, okay? I'll just show you this. Then let's see this. Let's plot this data. So this is how the data looks like. Let me give it some labels also. This is how the data looks like. I'm going to apply k-means to this just to show you. K-means will not identify these two clusters nicely. Okay. I'm going with two clusters. So these are the labels, by the way. And this is what k-means outputs. And then we'll do the clustering on top of this. Just see the results of the cluster labels. So give the colors as per the cluster labels. I'll show you the legend as well, just in case. With okay, this two, right? Two clusters. Do you see this? So do you realize that like k-means doesn't do work well? I mean, doesn't work well for this type of data. Okay, and let's say this is cluster data. Okay, so k-means doesn't do well on such type of data sets. Okay. What do you think? DBScan will handle it? Any guesses?
Yes.
Yes, it will. You will see this. DBScan will cluster it nicely. Okay. So this is the result using DBScan. Okay, there are two cursors. Do you see the results? So this is DBScan cluster data. You can see that DBScan identifies these two clusters well. All right. Now let's do clustering on say the bigger data set that we have. Before that, I want to show you on another data set. Okay. So I'm going to take say two of the features from DF. So maybe I'll take these features, age and this, okay, create in phosphokinase. Okay, let's take these two. Okay, so let me take some numeric features. Okay, I'm going to take these numeric features. Okay, these are numeric features. I'm going to take the top two of those. LOC. Oh, okay, sorry, just a second. I need the integer locations. So I'm taking the top two features and let me save it in X now. Let me store only the values. Okay, so that way. So this is your data, by the way, age and the two features. Okay. I'm going to show you first how the data looks like. So this is how the data looks like. Okay. I've taken the top two features, top two numeric features. So this is how the data looks like. Okay. After scaling. All right. Okay. Shall I use another set of features? This doesn't look that great. Okay, 1 second. Let me take the first and the third feature. So all features are kind of scattered to the left. But anyways, this is fine. Okay, I'll use these. Okay, I'll use these. Okay, I'm going to show you how to use showing you the results of k-means. Or rather, I just want to show you this DBScan because this is important. So I'm going to show you the results of these DBScans. So these are the results. Okay, it says that everybody is in 0. So what does that imply? What does that imply? Think about it.
One cluster.
One cluster only. Okay, so it has automatically clustered everything into one. Now, the default value of this radius is 0.5. Okay, default value of this radius is 0.5. If you look at the data, do you agree if I draw a circle around any point, it will be very large, a radius of 0.5.
Yes.
Okay, if you draw a circle around any point, 0.5 radius is very large, right? That's why you see it. That's why you see one cluster only. I'm going to reduce this. Okay. So I'm going to make it say 0.1. What do you think will be the number of clusters now? More or less?
More.
More. Okay. In general, I just see actually one cluster only, but some have become outliers. Do you see? -1s are there. Okay. So a lot of these points have become outliers. Let me show you what are these points. Okay, let's see this. Just need to plot this. This go with this. This. So this is how your representation is. Okay. Oh, it's doing 0 and 1. Should be mine. Oh, I'm plotting this range of 2. My bad. So this would be np.unique. You have to go to this DB labels, get the unique labels from it, and convert it to a list. Okay, do you see which ones are outliers? And they seem like it, right? Yes or no?
Yes.
Okay. So by the way, the min samples value is around -1. Okay. Sorry, min samples value is 5. Like if you look at the default value, here min samples is 5. So at least 5 min samples have to be there for a point to be categorized as a core point. Okay, or you can say that at least 5 points need to be there. I mean, for a region of 5 points to become a cluster. Now, can somebody argue why these 5 points are not in a cluster? Because the distance between this point and this point is more than 0.1. Yes or no? Does it seem like it, that it is more than 0.1? It seems to me that way. Otherwise, these 5 points will also form another cluster. Let me make it say 0.25. Or maybe say 0.15. Okay. Do you see any ones here, or is it still big? No, I don't see any ones, right? Okay, but the number of clusters, do they have they reduced? Or is it the same? Let me just check. It's the same, more or less. Some of the clusters have reduced. Okay, let me make it say 0.2. Okay, I think some of the clusters have reduced again. Yeah, these all 5 points have been clustered now. Okay, I mean, you have to find a sweet spot. Okay, you have to find a sweet spot because some point is here, right? So as soon as you go 0.2, okay, maybe this point get clustered and they all fall in the same region. Does that make sense?
So even if I'll continue with 0.1 as my radius.
So this is going to be unclustered, right?
So and I reduce my minimum sample, then maybe this.
Yes, then that can happen. Okay, let's say if this is 0.1 and let's say the min samples is maybe say 2. Okay. Okay, this can, do you see ones here, right?
Yes.
Okay, so now you will see that, okay, that region is going to be a separate cluster. Do you see that? It makes sense or not? Any questions about this?
So even if I made min samples as 2, these all the 5 came into one cluster.
Yes. Maybe then the distance. Okay. Do you remember the definition for these boundary points? What was the definition for the boundary points? What are they responsible for?
I had missed yesterday's sessions.
Okay, so the definition for the boundary points was that they are responsible for connecting core points.
Okay.
Okay, so if any of the points is a core point, okay, let's say if there are no core points in a cluster, do you think that particular cluster will ever become a valid cluster?
No.
So that is the definition of it. Okay, so at least one core point need to exist. Okay, at least one core point need to exist. Let me just show you the core indices. That way it will become more clear. So these are the core sample indices. Okay. So these are those samples which are your core samples, like in the radius of which you have more than 2 min samples. So what I'm going to do now is I'm going to plot these samples. Okay, I'm going to make them red. So if in a cluster, okay, you have at least one core point, then you can make a claim. I believe that this point, okay, does it look like it? Yeah, I think this point will be a core point. Okay, even this point will be a core point. Maybe this point will also be a core. I'm not sure about this point though. Okay. This point will also be, at least actually all of them will be cores because like if you draw a circle around it, min samples is just 2, right? So you need to encapsulate just one more point. Yes or no?
Yes.
So you need to, so let me make it 3. Okay, let me make it 3 to make it more idealistic. Okay. Let me make it 3. Just a second. Have I done it correctly? Just a second. Okay, this is 3 now. I'll also compute the distance between this 3. Okay. So at least one core sample has to be there. I'm going to highlight these core samples in your data. Let's see this. Okay, let's see which points come as the core points. I don't think this point will be core. I don't think this point will be core. But maybe this point will be core. Okay, this point will be core. Even this point can become a core. Okay, even this point will become a core. But these two I'm not sure about. Okay, these two I'm not sure about. Let's see. This is definitely not a core point. Okay, this would be a boundary point for sure. Okay, I don't know if this is 0.1 or 0.1 or not. Okay, from the looks of it, it seems it's very close to 0.1 though. But let's see. Let's try to plot these points. So what I'm going to do is this. See this carefully. So for J in my sample indices, so these are my sample indices. I'm going to take these sample indices. So maybe say x of j. That's the first point. I want to plot this scatter of this xj. So I will take this j comma 0. This is the index of that point, and this x of j comma 1. And since I have 2-dimensional data, and then I'll be using the some color for it, let's say red color. Okay, I'm just overlapping with the red color. Okay, and I'm also highlighting with say a marker. Let's say the marker is a triangle. Okay, let's see this. Okay, do you see? Okay, these 3 are cores. Okay, but these 2 are not cores. Okay, because if you draw a circle around them, this and this maybe they are not encapsulating. Does it make sense?
So that means if I draw a circle, the 2 yellow ones would lie on the boundary of the circle and rest.
No. If you draw a circle around this point, let's say where my cursor is, which is not a triangle right now.
Yes.
Which means that it is only encapsulating this point. What is the min samples right now? 3, right?
3.
So for a point to become a core point, it has to encapsulate 2 more points, including, I mean, so the point is also included. So if it must not be encapsulating 3 points, right? That's why it's not a core.
Okay.
Okay. So this is like slightly far away beyond the radius. Okay. But if you make it say 0.2, this will also become a core. Okay, just to show you. Maybe say you make it 0.15. I think that will also become encapsulated in it. Just a second. Let me make it say 0.17. Okay, but let's plot these, even though it has been in one cluster now. But do you see that this also becomes a core? You just increase the radius, so this also got encapsulated. Yeah. Is this clear?
Yes.
All right. So this is your DB scan. You can see there is just one cluster. these triangle reds are your core points. I'll just maybe make the label size is a little smaller. Make it at 8. Okay, so that you can see it now on top of that. Okay, so these are your core points. Okay. Okay. Any other questions about DBScan? Okay, let me ask you this. If I give you a query point, do you think DBScan can predict? So let's say if I use predict on a point, let's say the point is maybe say 0.4 comma say 0.6. What would you think DBScan would predict it as? In k-means, how do you predict? Anyone who remembers, who has gone through the last class? With respect to what you predict?
Mean.
With respect to the centroid. Okay. However, we don't have any centroids here in DBScan, right? Yes, sir. We don't have any centroids in DBScan. Only k-means has it. So k-means uses the centroid as the representative point. So this predict function is not even available. So if you try to run it, right, it will not be running. Okay, it says that it has no attribute predict. So you cannot predict with the DBScan. Please remember this. Okay, there is no predict function with DBScan. You cannot use it for predictions. Does that make sense? Because there is no representative point for a cluster. So if you want to figure out the cluster label for a new point, you have to rerun the whole algorithm. Okay, that is expensive. So this is only DBScan can only be used for offline data. You cannot use it for streaming data. Do you realize one limitation with DBScan?
If we cannot
Yes.
predict something using an algorithm in machine learning, then what is exactly the use of DBScan? Because in machine learning, our objective is
There are online data and there are offline data, right? Yes or no?
yes.
Do you realize the differences between the two? What is the major difference between online streaming data and say the data that you have collected? All the algorithms that we have seen, they work with offline data, right? Only once you have collected it, you apply an algorithm and then you can test.
Yes.
Okay.
One data is dynamic, the other is static.
The other is static, right? So if you think about the streaming data, right? If you want to, let's say for you to apply DBScan, you need to wait for some period. So collect the data in that period and then you reapply DBScan. So DBScan is not an advisable algorithm when you have streaming data because you have to periodically rerun it. Yes or no? Otherwise, you cannot use DBScan. DBScan cannot be used for making predictions. You can actually reuse it if you are a little intelligent. Don't you think I can compute the distance between the, let's say, the closest cluster?
Yes.
I mean, but then you would have to implement it on your own, right?
Yes.
Okay, there is no such function that exists because there is no representative point. But if you want to use, let's say, some heuristic way of doing it, then you do that. Okay, then you do that. Okay, I'll show you maybe some other. I mean, let's try to modify the parameters. Okay, let's say I make it so for this data set, it's kind of very weird because it's already clustered on one end. Anyways, but I hope you got the idea for this DBScan. Is there anything else that you want me to show? Do you want me to show you how to get the boundary points? So anything which is not a core point and not an outlier will be boundary, right?
Yes.
Okay, if you look at this figure, what is the boundary?
The
This
yellow ones without
this is the only boundary point here. Okay, everything else has a a triangle on it, right? Okay, so let me show you how to get the boundary points. So this is your core sample indices. Okay. And these are my all the samples. So I remember I have taken 100 samples. So these would be the indexes of the 100 samples, yes or no?
Yeah.
Okay, from 0 to 99. Okay, I am going to convert everything to a set. Okay, have you guys used set operation?
Yes.
And how do you take the difference between two sets?
Just a minus.
Operator. So there is this minus also. You can use the difference function also. Okay, by the way. So these are actually your what we say those samples. Okay, these are those samples which are not coarse. Does that make sense?
Hmm.
These are not coarse, but some of them can be outliers, right? That's strange. Okay, just a second. That is strange. Okay, and let me just rerun it. Okay, I think I have rerun it and I'm not storing the values correctly. Just a second. Okay. So these are the core sample indices. Okay. Just a second. Now, what is this difference? That's 160, 72. I can see there are 4 points. So these must not be the core sample indices in anywhere. How many samples did
Not
I?
the for loop that you have used to plot the boundary points, in that
Uh-huh.
put J not in and then plot it.
I didn't get you.
In this 96th code, can
Mhm.
we simply do for J not in DB core sample indices? It will give me the boundary.
That will, no, but then those points will be outliers also, right?
Okay.
An outlier is not a core point, not a boundary point. Does that make sense or not?
Okay.
Okay. I understand what you're saying. I mean, I can change it like this. Okay. I can change it like this. No, the one thing that is freaking me out is this. Okay. Just see this. See, I have these 100 samples, right? I don't have exactly 100. Let me just see. It should give me actually 5 values, not 3. Just by looking at it pictorially. Okay. Just by looking at it pictorially, it should give me at least 5 values, not 3, because there are 4 outliers. So at least 4 points must be there. At least 4 points must be there. Okay, just a second. Let me see. How is this 294? Oh, we are running on, it's 300 sample data. Oh, it's not 100. I have 300 samples. Okay, that's what I'm confused. That's why I'm confused.
The heart failure data.
This is the heart failure data. Okay, so what was the name? DF, right? So I'll just use DF dot shape of 0. That's why I got worried. I mean, these results don't make sense. Okay. Okay. Do you see that now? I said 5, right? Yes or no? So 1, 2, 3, 4, and 5. It should be 5. Okay. Because there are 4 outliers. So visually it should match, right? Otherwise, there is no sense of it. Okay. So these 5 points, you can say they are outliers. And also, can I say, so you can say these are outliers plus your boundary. Okay. So what I have to do now is a simple thing. So I will just run a for loop in this for j in this out boundary. Can I say that if just a second, so I have the indexes of those points. So I will say that if if db dot labels of j is not equal to -1, okay, then this point will not be an outlier, right?
Yes.
Okay. So let's just print the sample value, the sample index. So there will be just 1. So this is essentially that set. Okay, this is the index of those samples that are boundary points. So this is a 70-second. This would be this point. So I'm going to plot this point just so that you can see. So I'll just run a for loop. Maybe I'll make it a star. Okay, I'll make it a star here. Shall I put the whole code here? I will put the whole code here so that you can see. I mean, this will be generic, right? In that case. Let me make it say green. And a marker, I'm going to make it a star. Okay. So this would be your okay. Do you see that this is the green point? Does that make sense? Shall I increase the size of it?
Yes.
Let's make it 50.
Yes.
Do you see that?
Yes.
So this is a boundary point now. Okay. Alright. All right. Okay. Any other questions about this? About DV scan? Should I move ahead? Do the next one?
Yes.
Okay. Let's see this. I'll use the same data that I just want to show you. Okay. If I use this data again, on this one. I'm using this data again. Let's plot it as I have already plotted it. Okay. So this is the data. I'm going to reuse this. I'm now going to apply agglomerative clustering on it. So go to sklearn.cluster, import agglomerative clustering. I hope I've written it correctly. So I have to provide the number of clusters. Okay, let's say I want 4 clusters, and then you can, okay, well, let's go with 2 because I'm using this data only. Okay. Which linkage do you think will give me the correct result? Which linkage do you think will give me the correct result? Those of you who have studied, who have gone through the last class. Which linkage do you think will give me the correct result? Or which ones do you think will give me the bad result? What are you sure about? We saw many linkages, right? Single, complete,
Yes.
wards, average, centroid. So which linkage do you think will give me the better results here? Okay, think about this. If I use single linkage, don't you think the next point will be the closest point here? Because every point is a cluster in itself, right? Originally. So single should work well here. Yes or no?
Yeah.
I'll show you with single linkage. It will also be able to do it correctly. But if you use, say, average linkage, this will fail miserably. Okay. So let me just plot it for you. 1 second. So you are now looking at agglomerative. Okay, do you see that it clusters it very nicely? I'm going to show you another linkage. Let's go with, say, complete. This will also fail miserably, in my opinion. Okay, it will not work. Let me show you Ward. Ward will also not do well because Ward focuses on minimizing the variance. So if you focus on minimizing the variance, these points and these points should be close by. So they will be put in the same cluster, this and this. Okay. Let's see. Okay, do you see that this and this has been put in the same cluster?
Yes.
And this is what I was referring to. Okay. If you think about, say, average linkage, that will also not work well. So only single works well in this case. Okay, this is your average linkage. Okay. By the way, there is no centroid linkage in this. Okay. In this function, there is no centroid linkage, but I'll show you one other implementation where centroid linkage is also present. Okay. If you write centroid here, it will not work. As far as I remember. Okay, it doesn't exist. Okay. Let me just show you the outputs. Okay, it says that okay, these are the only options that are available, but there are other functions which support both of them. There are other options which support both of them. Okay, so let me show you how to make a dendrogram. So you need to go to this SciPy library, go to cluster, go to hierarchy, and you need to import two things: linkage and dendrogram. So which linkage do you want me to compute? Give me a name.
We'll go with single.
Okay, let's go with single. So let's go with single linkage. Okay, so this is here called as method. Yeah. The names of the arguments are different. Okay, this is a data X. Okay, let's call it as LNK. So it has computed the linkages for you, and now you want to plot the dendrogram. Okay, so you can simply provide these linkages back to it. And let me just show this dendrogram. I'm going to increase the size of the figure. So let's say fixed size is say 20,20. Okay, so it's relatively big. So you can visualize it. Okay, let's see. So do you see that, like, because they are all equidistant, that's why they all got merged at the same distance. Shall I reduce the number of samples
Okay.
so that you can clearly see what is printed at the bottom? So at the bottom, you see that these are the indexes which got clustered. Okay, so maybe I'll just reduce the samples just to show you. Maybe I'm going to take 10 samples. Or shall I take 10 samples at random and okay, I'm going to take the top 10 samples. Okay, this is how the top 10 samples are. Okay. And I'm going to show you the plot as well for these 10 samples. So you can understand what is happening. And I've taken this top 10 samples. Okay. One second, what's the problem? Oh, sorry, and you have to cluster it again. So these are the samples that are there. Okay, and if you cluster it, it looks like this. This is a dendrogram for you guys. Okay. Okay, so it is telling you that, okay, initially, what's the lowest point? It is the lowest point, right? 4 and 9. So samples 4 and 9 got merged first. Do you want me to print the index on top of the sample? Do you want me to print the index on top of the sample?
Yes.
Do you want me to print a number here on top of it? Okay, so that you can see, okay, so which do you think should be merged first? What do you think is 4 and 9? Is actually this.
The nearest.
Okay, the ones that you see here. Okay, so I'm going to print that. Okay, just a second. I think there is this function called as annotate. I have to look at the syntax of this. Okay, just a second. Sorry. Actually, matplotlib is there in MATLAB also. They follow almost the same syntax. That's why if you don't write Python, it will show you the matplotlib for that. Okay, 1 second, I just need to check. Okay, this is how I do it. I would take, okay. So what is it that that you want me to annotate? The index number, right?
Yeah.
Okay. So let's run a for loop for j in this range of this.
So 10.
I'm just writing it like this, okay, so that you are, so you can run it for anything, okay? And then I have to say annotate. So we want to annotate with the index j, okay? I'm going to convert it as a string. Okay, this is important. This is the location where you want to annotate, okay? So this is the location, okay, so it has to be done intelligently. Just a second. Oh, sorry, this is just a name, okay? This is, I believe, the text that you want to annotate. Just a second, let me think. Okay, I think this is the location xy. So location of xy would be the coordinates, right? So this would be x of j of 0, and this would be x of j of 1, okay? This would be the location of this xy, okay, and this would be the location of xy text. Okay. So you need to plot it a little above, okay? You need to plot it a little above. So I'm going to keep the x-axis as the same, but y-axis, so I'm going to plot it slightly above. So if you look at this point, okay, what is the y-axis for it? Around 0.2, right?
Yes.
Okay,
Yeah.
to plot it maybe slightly just above this. So let's say 0.07, okay? 0.07, just slightly above this, maybe say 0.05. Okay, so I think this is done. I don't need anything else. Okay, do you want me to do it in a specific color? Color is okay, right? Okay, I
That's
will
fine.
use this arrow props and all. Okay. Okay, there is one which is mistaken. Okay, just a second.
XY you have given 2 times.
Oh, it's XY text, right?
Underscore was there in it.
Where?
XY underscore text, I think.
Okay, just let me recheck this. No, it's actually giving me error here. Okay, it is not. Just a second. So this is the plot. Okay, I have to do it with the handle. Okay, got it. So this has to be done like this. So let's say this is SC comma AX. Like this, AX dot animate. Just a second. I think I could do it like this. So first of all, call it on the subfigure. Okay, then I can do this. This should be SC only. Yeah. I can just, what was the name that they were giving? Fig. Okay. Looks all right. Okay, do you see that now? 4 and 9 got merged first. Look at the plot. Yes or no? Shall I reduce the size so that you can actually see, maybe say 10, 10? We just have 10 points, okay? Okay, so 4 and 9 got merged first, and then 3 and 7. If you look at this, 3 and 7 are the ones which are at the top. Does this make sense or not? If you were there in the last class, can you make
Yeah.
note of it or not?
Yeah.
Okay, So this is how you can annotate on top of your data and reuse this. If you want, you can actually just push it slightly above, or is this fine? So 0.05 for this data is actually a decent number. They are very, very close. It's the data is already kind of normalized. Okay. All right. And this is how you use agglomerated clustering. You can do any dendrogram. In this dendrogram, you have actually centroid as well, in case you want to use centroid. Okay, you have the centroid as well. Do you see it runs with centroid also? Okay, you have centroid also. And you can provide average also here, I believe. Okay, so average is also there. You have VOD, and there are a few others as well. Okay, if you want, you can check them out. Single, complete, both are there. Okay, single, complete, both are there. And this is single, this is a complete. So this one does support your centroid also. Okay. I think 10, 10 is still big, maybe it's a 6, 6 or just a small one. Okay. Now this is enough. Any other questions about clustering? Anything in general? Do you think this agglomerative supports predict? Is there any representative? Do you think agglomerative supports predict? Is there any representative for any cluster? Yes, people. Is there any representative for a cluster? So these are the clusters that you get. Okay, let's say if I make say 1 comma say minus 0.2, or maybe say 1 comma minus 0.3. Okay. Do you think it will predict anything? What's your best guess? Is there any representative again? There is no represent. I don't think this will support it. Okay, it has no attribute predict. So unlike in k-means, which supports this, you can say prediction of offline data, this algorithm requires you to run it again. Okay, even this one requires you to run it again. One suggestion I have for you is, if you are really interested in reading about more clustering algorithms, I suggest that you read about Birch. I suggest that you read about hybrid of this dbScan and agglomerative, which is also called as hierarchical clustering, by the way. Hierarchical clustering. Okay, there is a version called as HDBScan, hierarchical dbScan. A good algorithm, you can, so these are some suggestions from my side. Okay, you can explore these. And maybe you can check out this Gaussian, k-means with Gaussian mixture models. Okay. K-means with Gaussian mixture models. Okay, so you can use this. These are some interesting algorithms. There is one more. So dbScan is actually the better version for optics. So optics is also present in sklearn, but dbScan is the extension for optics. So if you're interested, you can read about optics as well. Okay. These are some suggestions from my side. If you are free sometime, to explore it. Okay. So these are some other popular algorithms that are there. In your curriculum, there is just one, k-means. These are some suggestions from my side. Okay. Any other things?
Why is it the curriculum is designed in such a way that supervised learning we had like gone into so much of depth, but
No,
unsupervised?
you have not. You should thank me. Okay. See, Shilpa, your I mean, if you look at your supervised learning, right, just out the number of topics that are there. Okay, and see how much time is allocated to it. And think about how much time I have spent and how many variants of, say, every algorithm we have discussed in detail.
Yes.
So I have given you those extra stuff. Okay, it's not there in your curriculum, but you need that, like when you actually, start working. Okay, so it's not that your curriculum. So your curriculum makes you, what we say is, they only talk about the fundamentals. Okay, But when you start working, right, you will realize that there is so much beyond fundamentals, like there is no limitation to it. So the purpose is just to just ensure that, okay, you have all the necessary prerequisites. So this is like saying, when you start your journey, do you when you're learning maths, what is the essential thing that is taught to you? Board maths only, right?
Yes.
Do you think you need anything else? You need much more, right? If you think about it.
Yes.
Then you learn it over a period of time, right? So with time you progress. It's the same concept here. They want to give you the essentials. So if they give you everything, then they will need probably, say, a couple of years to do this.
Yes.
You also want to become a data scientist, right? As soon as possible or not. So there is no limitation to the time. Like you can learn so much on your own. So once you know the fundamentals of, say, most algorithms, I can assure you this, if you start reading research papers on your own, you will have some comfort at least. Okay, you'll have some comfort at least. You'll be comfortable with reading them. Even if they are from, say, the best conferences in the world, written by Stanford or, say, people from MIT or, say, any Ivy League universities, if you think about it, if that's what the benchmark for you is. So you can understand their papers also now, even if it has a lot of advanced maths.
Sanatan, can I interrupt you for a second here?
Yeah.
Sanatan, do we have any since you're in academia, do we have any papers or research papers published by the Indian Institute of Technology
Yeah.
or RECs?
Yeah.
I think that would be more relevant than we referring to the other nation, these things,
But
research papers.
what specific paper are you looking for? In what domain?
See, I'm looking at mostly NLPs.
No, but what, see, ML, again, anything that you say, right? Say ML, say NLP. These are subjects in themselves. Let me tell you, NLP is divided into three parts further.
Subdivided, okay.
And so they are three subjects, okay? And whatever you're learning right now, let's say in a book, it is nothing but the assimilation of, you can say, the research proposed by different people, which has been accepted in the community over, say, the last decade or the last 2-3 decades. So when you're reading a book, right, it's nothing but a assimilation of what people have proposed. Right? So it's not just that, okay, there is, if you say NLP, so it's not one person. So there are millions of people who have contributed. So even if there is a slight extension that gets added to the books, that's why there are book updates, right? You see versions of books.
Yes.
Right. So it's not just one person. So let's say if you talk about, okay, if papers are coming from IITs, let me tell you, every year, every IIT publishes around 5,000 to 10,000 papers. Okay, but they are in niche domains. They are in niche domains. Okay, so if you ask me, okay, are there any papers from about, say, k-means? Let me tell you, there are actually 50 variants of k-means that are out there. Just 50 variants of k-means. Now think about it. 50 variants of k-means may be from India, but if you look at across the world, there might be 500. India is actually one of the top publishing nations. So I think first is the US, then you have China. So China and US are ever competing, but US publishes quite a lot. And then Indians come. So there's a lot of research done by Indians.
Okay, Sanatan, thank you.
Yeah. But if you want some specific paper, right, which has everything. So typically conference papers are 6 to 10 pages, some number in between. Journal papers are, and they will do very, very specific research. It's not that they will just take up clustering and just implement it. Not like this. Research is something novel. Okay. So you find the gaps, you try to bridge them, or you have come up with a totally novel idea which has not been done before. See, obviously there are shitty conferences and there are shitty journals as well. Yes or no? See, those are also money-making businesses, right? So they also have to survive. This is also a business, okay? Publishing is also a business. Okay. Which is the best publisher that you know?
Usually, I just scroll through Kindle and whatever I get, I read it.
No, but let's say
Like
if
hardcover, I hardly have any knowledge about hardcover publishers.
okay, so I mean, I think you must have heard of this company called as IEEE. No, Springer, ACM, elsewhere. No.
Like Penguin and all these kind of things. I know the local publishers.
No, they are like brands. Okay, so let's talk about say Nike. You are aware of it, right? Shoes.
Yeah.
Okay, so Nike publishes. Nike produces a lot of shoes, right? So is each shoe like 10K or 20K? No, right? In India, you sell it. You see shoes worth say 1,000, 1,200, 1,500 also, right? Similarly, these brands have conferences and journals which are like very, very poor. Okay. So there are tiers to it. Okay, there are tiers to it. So every publisher has a lot of, I would say, majority of the chunk is bad, and only a few good ones are there. Okay, only a few, but they have to survive, right? Okay, so publishing is also it's a very different sector, I should say. Okay, if you can read about it, perhaps you can get enlightened about okay how businesses work, how academia works, how research works. This is not very. It's not a typical topic. Okay.
I get you.
Okay, so these are your clustering algorithms. These are some suggestions from my side. If you're interested, you can read about these. Anything else from clustering or anything that we have done before? So I just want to ensure that we have finished all the topics. Give me a second. Yeah, we have done. See, if you look at your clustering, right, there is just 2 hours allocated to it. Yes or no? Just see this. And how much I have taken? Probably 6 now. The last 3 sessions we have been doing clustering only, right?
Yes.
So I have tried to give you more than what is there in your curriculum, and you will see the usage of it as you, go to the industry and dig deeper. Okay, let's start with the last topic, which is NLP. So let's do some preliminary discussion on NLP today. So I'll just change this and maybe write say okay intro to NLP as well. Okay, so I have 2 datasets with me. One is a movies dataset, which I downloaded a couple of days back. And there is one which is a tweets dataset, the Twitter tweets dataset. What do you want me to discuss? Tweets. Okay, let's go with this stuff. Okay, these are all downloaded from Twitter. Sorry, this is the tweets dataset is the Twitter dataset only, but it was downloaded from Kaggle. So let's load this. Let me just make a comment here. So NLP is the domain where we process or you can say work with human readable text. Human readable meaning that you can read it and understand it. Okay, so it can be in any language, but we'll focus only on the English language. All right. So if you read about any text, okay, let's say if you go to any e-commerce website, what do you think is the most useful component of any website which helps you decide, okay, this is the product for you? Which specific characteristic about a product helps you decide that, okay, this is what I want to buy? This helps you make a decision. Reviews, right? Okay, so reviews are human readable text, right? And what could be the problems with reviews if you think about it? Okay, let's try to understand some of the problems. So what
reviews like mostly will be like like people sitting on computers and just writing the reviews. People who are not actually bought the product, but they are just writing the reviews.
That could be a problem, right? Okay. No, but let's talk about text, not about like how they are trying to fool you.
The decision making part, I'm saying.
That is obviously there. Okay, that is obviously there. But let's think in the sense that, okay, it's not just about reviews, it's about a generic problem with text. Okay, so what are the problems with text?
You cannot, like, if there is a text, it's if I give a rating, then I can easily judge whether it's a positive rating, negative, or an average rating. But with text, it's not
Hard
that
to gauge, right?
straightforward to
Okay.
classify.
Hard to gauge the polarity of the text.
Yes.
Okay, I mean, especially for machines, it will be difficult, right?
Yes.
Okay, okay, what else? Think about, say, text processing. Do you think that whenever you are writing a review, you use complete English words,
No.
right? So you don't do that, right? So let's say we can say incomplete words. Okay, sometimes we miss the words. Okay, sometimes we write
Improper sentences.
grammatical errors. Okay, there are grammatical errors. Okay, we use a combination of languages. Okay,
Nothing here in the combination of languages. I have like a different view. Like, so for example, if I'm conversing in my regional language, like be it any part in India, but still I'm using the English letters as the medium.
correct. So that is like how you represent your text, right?
Say like, for example, if the machine is learning,
Mhm.
so if the machine is reading it, it will read it like alphabet to alphabet. It will not,
That-
even if it reads as a word,
Machine
it
doesn't-
means
Not there
something
in the
else to the
dictionary.
machine, but it means something in the regional language, correct?
No, machine doesn't read letters or words. You'll have to be I mean, you need to work with numbers. Okay, so we'll see how to process your data into numbers.
No, you got what I'm trying to tell you, right?
I understood. So typically, when you use your native language, right? So there is a what we say. Uh, in Hindi, I know the term. It's called as lipi. In English,
Yeah,
doesn't.
exactly. That was what I was trying to tell you.
Yeah. In English, I don't know the name for it. So
Script, maybe?
what is it?
Script.
Maybe, yeah. So the script may be different than English, right? So see, you will have to understand the text as a data scientist, and then you have to represent the text as a number, because when we are going to train a model that works with numbers, right? It doesn't work with text. Yes or no?
Yes.
Okay. Another problem that you can think of, okay, let's say, okay, if you say, I'll just put it like this: script issues. Okay. Does that make sense?
Yes.
Okay, so that is totally all right. So script related issues can be there. Anything that we think of.
Can we say size, length issues?
So the idea is not every text would be in the same representation, right?
Yes.
Length of every text is not the same. So typically raw text is what? Unstructured, right?
Yes.
Okay, so we have to structure it. Okay, needs structuring, right?
Yes.
It needs structuring. You need to represent the text in a tabular format. Okay. What else? See, there's many.
Sometimes we have emojis in the text.
Okay, so can I say meta characters, special characters, or meta characters?
Yes.
Okay, which carry special meaning.
Yes.
Sometimes they don't. Okay. Do all words carry important meanings?
No.
Okay, so these are called as stop words. Okay, not all words carry special meanings. Not all words, you can say, contribute to the let's say, to the task. Okay, to the final prediction. Anything else comes to mind? So there are very, very big challenges. Okay, think about sarcasm. Is it easy to determine sarcasm? As a human, we fail, right? How would see Sheldon fails? If you watch Big Bang Theory, then you would relate to it. What I'm saying. So people, I mean, for people also, it is sometimes difficult to recognize sarcasm. Anything else comes to mind? So I'm just jotting down all the problems with text, and they will require special handling. Okay, they'll require special handling. Anything?
Textual meaning of some words.
Semantic or syntactic? Okay. Let's say semantic versus syntactic. Can I put it like this?
Yes.
Okay. Okay. So, I mean, obviously, the list goes on if you try to think about it. So, just a second, please. Guys, I'm sorry. So the idea is we'll be working with a data set. Most of the data sets that you will get, right, there will be obviously having some of these problems, but not all of them at the same time. So you have to deal with each of these problems. I'm going to show you how do you deal with the major problems. Okay. So let's start with some of the basic things. So let's load this data set. Okay. Okay. That is present in my desktop. And this is called as tweets.csv. Okay. This is the data that you have. Let me print, say, the top few rows. So let me just print the top two. Just a second. So you have the tweet ID, a unique identifier for the tweet. So it is telling you the sentiment about the tweet. Sorry, people. And I'm not well for the last 2 days. Like since the last 2 days. Okay. So we have this airline sentiment, which is neutral and positive. There is some score given to it as well. You can kind of ignore it. Let's focus on the text part. This is where the text is. Okay, this is where the text is. So I'm going to show you the text part of it. So these are your tweets. Okay, these are your tweets. So this data set contains the tweets from airline customers who have just deboarded, like from a flight. So, and this is a data set from US customers. So when a person is completing the journey, right, they typically write about the experience. So these tweets talk about that. Okay, these tweets talk about that. So some of them are positive, some of them are negative. Okay, you have data like when the tweets were created, what was the location. For some of them, location is given. For some of them, the location is not there. You have the time zone as well, when it was posted or where it was posted. Okay, so you have all these details of what airline it is. Okay, what was the name of the, you can say the account which posted it and things like that. Okay, let's try to understand some of the basic things. Okay, let's look at some of the texts. Okay, let's look at some of the texts. I'm going to show you maybe say this text. Let's look at say this first one. Let's look at the first one. This is the first one. Now, do you see what are the problems with this? Like obviously this dot 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 is there. Understanding this would be a problem. Okay. There is no proper sentencing, right? If you think about it. Plus, you have added commercial to the experience, and then the person writes tacky. Okay, this is like what we call it as teenagers' language. Okay, so that's not. I mean, in a proper format. And one of the questions is, how do we represent this text into numbers? So think about it. Let's say if somebody gives you a piece of text, okay, how would you represent it into numbers? What would you do? Anyone?
See what are the positive and negative or neutral words in that particular text and accordingly assign number like we do for rate.
Sentiment classification. Is the task to do sentiment classification? I'm just asking you to first format this into some data set, into some tabular format. I think you are trying to do sentiment classification. Yes or no?
Yes.
No. That's like the final task. Okay. See, let's say you are going to apply an algorithm, right? The algorithm that we have studied. So you have to give it a set of features if you think about it. So what should be the features? First of all, think about this for a data set. What should be the features? See, in a text data set, what do you think the features would be?
The like you said, stop words are the words which are not.
The words, right?
Yes.
Okay. Can I say I can use phrases as well?
Yes.
Okay. I can also use maybe say combinations of words, which are again types of phrases. Okay. Okay. Maybe emojis, if they make sense.
Punctuations.
Punctuations. Okay. Some special characters. Okay. So these will be some relevant features, right? Yes or no? Now, if these are the features, okay, let's say there is this feature called as say tacky. Okay. If this is a feature called as say tacky, this is one feature. For this document, for this tweet, what do you think we should measure for tacky? If tacky is a feature, what do you think we should measure? If the word is present or absent, right? That is one thing that we can do.
Yes.
Okay. So for this given tweet, let's say first tweet, tweet 1. Okay. We can measure here, okay, what value to put. So this value can be the presence or absence of that word. Yes or no? So there might be many words, right? Like this, if you think about this, there is this word called as experience. Okay. You can think of say added. Okay. You can think of words like people. Okay. Think of words like say America. Okay. So some of the words are present, some of them are not. So we have to decide, okay, the value for a word, if it is present or absent. So for this tweet, is tacky present? The answer would be 1, right? Yes or no? Does this make sense? Do you see that tacky is present for this tweet, right? So you can simply write it as a 1. Does that make sense or not?
Yes.
Okay. Can you do something else? Instead of counting the present absence, what can you do? Think. Can you count the number of times the word is present? Do you think every word would be present only one time? Always?
No.
No, right? So this is called as term frequency or word frequency. How many times the word is present? Okay, so that can also make sense in some cases. And obviously there are, okay, think about this. Which words do you think will be repeated the most?
Prepositions and articles.
Can I say those stop words which do not play much role?
Yes.
Okay. So these will be stop words, right? Okay. So can you think of a way? So if you give term frequency as the value, right? So stop words will get more importance.
Yes.
Okay. So one way is to eliminate the stop words. Okay. One way is to eliminate the stop words. But will you be able to capture all the stop words? Probably not, right? It will require you to do a lot of digging
Yes.
because you have maybe millions of tweets. Okay. So can we do something else? Can we find another representation instead of this term frequency? Let's call this as term frequency inverse document frequency. So we will see that, okay, it will normalize the frequency score. Okay, it will normalize the term frequency score. Okay, based on, you can say across all the documents. Okay, across all the documents. So we'll see one way to do it. Okay, we will see one way to do it, which will give less importance to stop words and more importance to, you can say, rarely occurring words. Okay. My question is this: do you think a word is important if it is repeated a lot of times and is also present in, say, all the documents?
Yes.
Do you think such a word is important?
Yes.
No. Think of a feature which is always one. Do you think it is important? Think of a feature which is always present. Do you think it is important? Which is always one.
We can generalize it and take it like it is all.
No, you can just remove it, right? If it is always present, then it is not informative, right?
Yes.
So do you think we can normalize the score based on its presence or based on its frequency across all the documents? We can scale the importance of a word if it is present in more documents, right?
Yes.
So if it is present in more documents, I should reduce the importance or increase the importance?
Reduce.
Reduce the importance. Okay, so that is the idea behind TF-IDF. We will see that, okay, how it is done, what is the formula and all that in the next class. Okay, let's discuss some more things. Okay, so these are some of the ways in which you can put the values, okay, in which you can format the data, structure the data. Okay, how do you identify the combination of words which are important? See, emojis and punctuations are straightforward, right? Don't you think for that we will require domain expertise for these two?
Yes.
Like in English, we can understand it, right? But there might be some special meta characters which might have special meanings, say for airlines. Okay, so maybe you need some domain expertise. In English, it is easy to tell. Okay, maybe in some other language which we are not well versed with. So let's say if you guys know Telugu, then you might be knowing, okay, this symbol means this. I don't know that. So for me to come up with features, right, I might do a bad job. So I need some domain expert or some person who can tell me this is what this means in Telugu or any other language, say Tamil, Kannada, which I don't know. Okay, so domain expertise is important. I hope you have realized that. Anything? Okay, what about these combination of words? Which combination of words do you think you will prefer as features? Which combination of words do you think you'll prefer as features?
Less appealing.
That is one way to say it, okay? But do you think, let's say, if I can use the word like, say, hey you, should this be a feature?
No.
Why? Okay, let's say good job.
Good job should be.
Okay, let's say in this context, okay, it was you can say smooth journey.
Smooth journey is, yes, it is important.
Do you see that there are these pairs of words that I'm talking about and follow certain parts of speech? What is smooth in English?
Comfortable or
No. So you know about parts of speech, right? Like if it's a noun, it's a verb, it's an adverb, adjective.
adjective.
So it's an adjective, right? And what is journey?
Journey is a noun.
Now, so can I say that the combination of words which follow a special ordering of a part of speech,
Okay.
and it is also repeated in some of the documents. Do you think that can make a good set of features?
Yes.
Okay, so with a decent term frequency, as well as you can say some part of speech ordering, so that can make a good combination, right?
Yes.
Can we do it for triplets, like 3 consecutive words?
Yes.
Can we do it for quadruplets? We
Yes.
can, right? I mean, the way we want to go up to, I mean, it's your call. Okay. Do you think we should actually look at, say, beyond 4 or beyond 5 or beyond 3? Does it
No.
make sense?
No, maybe not
I mean,
beyond.
their occurrence would become very, very small.
Yes.
Okay. Only in 1 or 2 documents you might see it. And if a feature is very, very rare, it may not be very super useful. Okay. So it should be present somewhat in some of the documents. If it is present only in one, it's not very useful, to be honest. Okay. Okay. So we've spoken about the combination of the words. Okay. One of my questions is this: when you break this type of a sentence, this raw data, this unstructured representation into this type of representation, what is lost? What do you think? What is lost when you convert this type of data, this raw data, into this type of representation? What is lost? There is something that you're losing upon conversion of unstructured to structured. These are the things that we have to discuss. Okay.
Information.
It's lost. Do you think that if I give you this representation, you can retain this representation back?
No.
But if I give you this, can you retain this?
Yes.
Right. So vice versa is not possible, right? So what is it that I'm losing?
I'm losing on the meaningful or the information.
Semantics are lost.
Yes.
Can I say the ordering is lost?
Yes.
Semantics.
Semantics are lost, ordering is lost, grammar is lost, right?
Okay, okay.
Okay, so essentially there is no grammar left out. So you are only relying on the individual tokens, individual words or combination of words. Okay, so semantics get lost. So sometimes we don't really care about semantics and sometimes we do. So let's say you are thinking of summarization. Do you think semantics will be important?
No.
Yes. You're trying to summarize something. Don't you think semantics will be important? Let's say if I
Yes,
give
of course.
a graph of 5 lines or say 10 lines, without the grammar you can summarize it.
No.
It is difficult, right? Okay, it is difficult. So semantics is important. Now think of just predicting sentiment. Do you think semantics are important?
No.
No, semantics are not important because you can just think of if a positive word is there or a negative word is there, you're just using those combination of words which are positive and negative. Okay. So semantics don't play a role there. Okay. Think about, say, similarity matching. So you all use Google, right? When you type a query on Google, it retrieves you a set of documents. So it is essentially doing some kind of matching, right? With your search query and the documents it has crawled. So do you think semantics are important there?
No.
No, right? So there are some applications for which semantics are important. There are some applications for which semantics are not important. Okay. So for simple tasks like information retrieval, sentiment classification, okay, you don't need semantics. So you can convert it to the structured data very, very nicely. Okay. But for tasks that require preserving the semantics, okay, let's say language translation. Okay, from one language to the other. Do you require semantics? Think. For converting one sentence into another language. Can you do it if I remove the stop words? Will it be possible? So if I just give you, say, commercials experience tacky, can you translate it to another language?
It
No, right?
doesn't make any sense if I translate it as is.
Semantics for this language translation. So think about Google Translate. Don't you think it needs the whole sentence? Have you ever tried translating a sentence which is not proper? Google Translate will give you bad results. Okay, do try it out. So semantics are important there. Okay, so there might be applications where you need it. There might be applications where you don't need it. Okay, so think of say ChatGPT where you are doing synthetic text generation. Do you think semantics are important?
Yes.
Yes. Okay. So these are some of the things that we will do. Obviously, we will not be doing like these advanced stuff like building a large language model. Okay, that's beyond. Okay, but we will see, say, some of the tasks where you don't require semantics. If required, I'll show you some libraries which through the help of which you can directly tackle semantics. Okay, and what do you think is a big problem with this representation? Any guesses? With structured representation, especially with text, what do you think a big problem would be?
Number of features would be very, very, very high.
Be high, right? Okay, maybe in the order of 30,000, 40,000. Okay, for this data set, I can tell you the number would come out to be, if you just use single words, it would come out to be around 20K. Okay, even for this small data set, it just has around 15,000 or 20,000 tweets, 14,640 tweets. Okay, so even for this, you will have around 20K features. So imagine if I give you a data set about million tweets, you are done. Okay, the size would be exceptionally large. So what is it that we should do when the size of the features is large? We reduce the features. So we will see some dimensionality reduction techniques like principal component analysis. So size is an issue. Okay, size of the structured data is an issue again. Okay. Okay, so we need to reduce the features. Okay, what can you say about the density of this data? Will it be sparse or will it be very dense? Most of the features would be present or absent. Just think about it. It will be highly sparse. So especially in highly sparse data, okay, your models will actually fail miserably. Okay. So we need to think of and some, you can say, dense representations. So we will see some deep learning models that can give you dense representations. And then they have their own benefits. Okay, some of them preserve semantics, some of them they don't. So now that you have an understanding of where to use semantic preservation and where not, so you can choose your models accordingly. Okay. So okay, let's say size and the sparsity of the data. Sparsity of the data is an issue. Okay. Anything else that comes to mind? Okay. Anything else?
Some words have meaning as per the sentence. So if we break them.
Yes. Okay. Don't you think that? Okay. Let me just go up and maybe add it. Okay. It's a good point. English is actually very ambiguous if you think about it. English is a very ambiguous language. Okay. Can I say that? Ambiguous. Yeah, have I spelled it correctly? G-U-O-U-S. Okay.
Which spelling?
Is this correct or the previous one was correct? Ambiguous. No, this is correct, right?
Yeah.
Okay. All right. So the idea is like there are certain words which are context dependent. Think of the word bank. Do you think it carries many different meanings?
Yes.
So, think of the word say book. Does it carry many different meanings?
Yes.
Report.
Yes.
Let me tell you that if you choose, say, if you are thinking of 20 English words right now, out of those 20 English words, you can easily find one or two words that have different meanings in different contexts. So we need to do word sense disambiguation. Okay, we will also do this in your subsequent sessions. Okay, so this is important. Okay, anything else? Think. Okay, if anything comes to mind. So I'm going to tackle all these problems for you. So if you have something left out, tell me, I'll add more things. So even if it's not in your syllabus, I'll cover it. Anything else that comes out? Okay, do you want me to build some simple information retrieval systems? So think of the applications. So one of the applications would be sentiment classification, which is the straightforward application that one can think of. Think of information retrieval, similarity matching, Yes or no?
Yes.
Anything else comes to mind?
Translator.
Translation is something that you will probably not do. I don't even have the resources for it. Even Google Colab will fail there. Okay, so I cannot show you the translation part. But if you want, I can maybe give you a piece of code with the help of which you can do translation also.
Can
But
we
you
cover like
advanced understanding of transformer models. But that has not been covered for you. I'm thinking,
nowadays we have those help queries that are automated on like in many of the applications and fields. Like you type a message and then an automatic reply comes to you.
okay, let's say like Q&A or chatbot.
Question. Yes, chatbot.
So maybe I'll show you, okay, how, maybe I'll summarize, okay, how do you make a good chatbot? Okay, if I start doing it, it will require me at least 3 to 4 hours just to deliver the whole thing. Okay, I'll talk about, okay, how you can build a good Q&A bot.
Sanatan, just a second.
Yes.
Sanatan, like the other day I was watching a ad, okay, it was for Oppo, okay. So like what happens is like that guy goes to a European country, he goes to France, okay. He doesn't know what's the street sign, okay. He just like he puts the camera onto that street sign, and that gets translated into his Chinese language. So what's the technology behind it?
OCR plus translation. So first you need to do optical character recognition. Okay, so essentially in images, like when you show your, I mean, when you capture an image, right, through your camera. So the first thing is you have to recognize what are the characters or the words in it. Yes or no?
Yes.
That is called as optical character recognition. Okay. And then whatever characters you have recognized, you are calling a translation app on it. So what characters you have recognized, you will feed it to a text translator, which will do the translation for you. Okay. But this is a slightly advanced topic. Okay.
It's an app-based thing that what happened.
Yeah, I understand. I can give you 1,000 apps like this. Okay. Think of, okay, say image captioning. So I'll give you an image. Can you generate some text for it? Okay, let's say I have clicked the picture of maybe say your relatives and they are all smiling and maybe there is a cake in the middle. So what can you say about that image? So maybe
celebration,
celebrating a birthday of someone. Okay, maybe a special occasion, maybe anniversary, depending on if there is a bride in the center or something like that. Let's say if a male and a female are cutting the cake. Yes or no?
Yes.
Okay. So can you generate the text for it? These are called as image captioning models. Okay. So this is also possible. Okay. So it requires you to work with images. So it is a multimodal data. You have images as well as text. So you have applications for that. Okay. You have applications for that. If time permits, I'll show you this also. Okay. So see, for me, only the time is an issue. I can give you more and more details, but this is moving towards AI engineer role. This is not data science anymore. Do you realize this? You are now building apps. You are not doing data science anymore. Okay, so you are thinking of building development apps. Okay, so even Q&A, this falls under, but I will show you. Okay, I'll at least describe the things that you can do to do a good Q&A. Okay, even for this OCR and translation, if you're up for it, I'll talk about it. Okay, I'll tell you maybe the libraries that you can use. Maybe I can tell you right away. So OCR, you can use Tesseract. So there is an app called, there's an API called as PyTesseract. Okay, if you have watched the movie Avengers, do you remember what Tesseract was? Anybody who remembers? No, no one. Okay, and then you can integrate it with say Google Translate, or you can also integrate it with. There is a transformer model called as BERT. You can use BERT Translate. Okay, I will just show you how you can integrate with existing apps, and you can come up with a solution, and you can build your own solutions also. You can build your own solutions also. Okay. You can even train your own models to do optical character recognition. Okay. But you need to use PyTesseract for a special language. Okay. So this would be language specific. So if you're going to France, it would be French. If you're coming to India, it would be a variety of languages. So it depends, okay, where you are. So you have to train these models for specific languages. So you can actually use Google Translate with some, if you have some, if you can pay Google Translate, you can, by the way, I think you can only pass 1,000 queries in a day to Google Translate if you're using it for free. Beyond this, it charges you money, or it will block the access for after 1,000 queries. Okay, so this can be done. This can be done though. These are
like
yeah.
as you are mentioning Google Translate, like this is a thing which happened to me personally in the recent past. Okay, so like I was chatting with someone. This happened like on Twitter. Okay, so they unknowingly they typed in their language. Okay, it was in Arabic. Okay, so like that message came. So like I didn't understand. So the Twitter has that Google Translate thing, right?
Yes.
So I hit that button, okay. So, but it didn't translate. It just translated. I mean, what was typed in the message box, the same thing.
For every translation app, right? So if you want to make it generic, the task is actually very, very difficult. Think about it. What is
that
the
a bug?
have to do? Given a piece of text, if you want to do translation into a desired language, what is the first thing that you have to do?
Firstly, I need to identify or understand the language, right?
Yes. The first task is identification. Think about how many languages are there in the world.
No idea.
No,
200 plus.
Yes, just take a guess. In
200
India,
plus.
okay, take a guess.
200 plus.
No, in India alone, it's 200 only. What do you think? It's actually 5,000.
Ah,
There are so many native languages, right? I mean, see, I'm not talking about for every language there has to be a script. Okay, I mean,
yes, that's correct.
English, I mean, we can type it in any way that we want, right? But the language is there, yes or no?
Yes, totally agree.
They have scripts, some don't, right? And there are so many regional languages. Okay, so I mean, the number is huge. So if you think about doing, say, if you talk about, say, popular countries, there are around, I think, 206 countries or so. So if every country has one language, okay, so I assume that, okay, there are 200 languages. And then you think of training a model with, say, multi-class classification, which can identify one of those 200 languages. Don't you think it's a difficult task? These are 200 categories now.
Yes, yes.
Do you know that when the number of categories increase, you actually need more and more data? So I'll tell you this, okay, I'll tell you this. Let's say you're doing binary classification. Maybe you go back and also read about it. Let's say you're doing binary classification. You want to identify, okay, which language it is. You want to differentiate between, say, English and Hindi. So you can actually do this in a limited amount of data. Let's say just 100 samples. Okay, so 50-50 each. Let's say you add one more class. So do you think you just need 50 samples for the third class? That's the question. You just added a complexity of finding out the third class. Do you think it will be okay if you just take 50 samples for the third class? Or let's say if you want to increase this number to 10, do you think you just need 50 samples for every class? So maybe with 100 samples, when you were doing binary classification, you were achieving 99.5% of the results. But now if you think, if you have 10 classes, is it okay if I just do it with 50 samples per class?
No.
What you would probably require is maybe, say, 5,000 samples per class. See, I increased it so much, right? 50 to 5,000. Do you realize how much the samples that I need for, say, 200? Okay, to achieve the same performance. So, and what is the problem with supervised learning? Getting the label data. Who's going to tell me, okay, this is what language? I need to pay a domain expert, right? You may not be knowing about every language. Yes or no? If you are collecting the data yourself, Probably if I show you two languages which are unknown to you, you will not be able to recognize what language it is. Forget about labeling it. So there are a lot of limitations, okay, from the data collection side also, which probably when you do it yourself, you would recognize. And we don't do that, right? As data scientists, it's a data collector's job who made the data set. Okay, and then how do you extract features from it? That is data engineer's job. Your job is to just simply analyze, sit back and analyze, and then do reduction if required. Okay, so basically you do EDA processing and all that. But there are a lot of people involved from beginning to the end. So I'll show you. Okay, maybe we'll talk about. Okay, so I'll just give a description of this.
So we can have applications like this example was for OCR plus translator.
Yeah, it's your call. So you give me special examples. Do you want specific examples for this? For each of the applications, let's say I build a sentiment classification app in the context of say product reviews from Amazon.
Yes.
If you want say information retrieval, maybe I'll show you an app which can which can retrieve documents from say research articles. So you give me a PDF and I'll find another relevant PDF, okay, which is very similar to this. Does that make sense?
Yes.
Just a piece of text. If you give me a piece of text, I can do that also. Okay, but I'm going in a specific domain. So let's say research articles, like in academia, okay, or in industry. So think of, let's say, you are doing this Q&A. Okay, maybe you have you're trying to install a library. Maybe say some NVIDIA library like TensorFlow, or sorry, Google's TensorFlow, or maybe say NVIDIA's. Or I'll say PyTorch. Okay, I want to go through that. Do you think you go through all the documentation? Like when you're installing something? No, right?
No.
If I'm looking for a special thing, let's say you have a special question, which if you search in the document, would you be able to locate where that answer is? Probably not, right? If you have a very specific question, can you tell me what is it that I should do if this thing fails? These kind of questions, do you think are in your documents? Probably not, right? The answers to those are there actually in your documents. However, how do you understand the question semantically and retrieve that portion of the text which is important for me? That is what you're talking about, right? In Q&A. Yes or no?
Yes.
So we can do something like that. We can do something like that. But I'll be doing it very minimalistically. Okay, I cannot see every application would require at least 4 to 6 hours to build from scratch. Okay, so maybe I'll give you directions. Okay, this is what you do, and I'll show you maybe on a small data set. This is how you can do it. Okay, and then you can extrapolate it.
And then we can even have like rather than image processing and then text processing, we can have audio processing and then text processing. Like what nowadays it's like.
What you're saying is, I will have to end this
somewhere.
Yeah, and the ultimatum that I have received from Guvi is next week.
Okay.
So we have, I think, 4 classes only. Okay, so at least 2 classes I need for you can say going through the NLP topics. Okay, like the topics that are there in your syllabus. And beyond, let's say the last 2 classes, maybe one of them I'll show you how to build some apps. Okay, at least the fundamental processing part. And in the last class, if you just want to build apps, we'll dedicate the last class also for apps. Otherwise, we'll use it for doubt clarifications for any of the topics that you have studied with me. So I will essentially have maybe say 2 to 3 hours at max. So you either need to pick one, or I just do minimalistic implementation of all of them. Okay, and I'll tell you okay where to look at, what to do, and I can be very precise with that. Okay, but I don't have that much time, frankly. And so what you're asking me is actually to do project building. And for this, you already have 3 modules after this.
Okay.
Okay, so you have dedicated 3 modules after this, and you'll be doing similar projects along the lines.
Okay.
Okay, so there are 6 modules, not 6 sessions dedicated for this for you guys.
Okay.
But essentially, each of these things is a project in itself, right? If you think about it, it's not that it's just a simple task like classification or regression.
Yes.
You would want to deploy it, host it on say a website or say any app, and you would want to show it to the other users, maybe deploy it on your GitHub and all that. Okay, so I think you have gone through management of GitHub, right? Yes or no?
Yes. Yes.
Have you done deployment on services like Streamlit, Flask, Heroku, and all that?
Stream.
Probably not. Maybe some other instructor will come and probably teach you these things.
Okay.
So I think this would be probably Shabrinath Premlal who would come and teach you all these things. All right, I'll stop here. I'll upload this notebook and the data sets that we used today. Any other questions?
So Sanatan, we'll meet again on Monday, right?
Yes, we'll be meeting on Monday now. Any other questions? So next week would be the last week with me.
So basically the end of the
Yeah, end of the NLP module.
not the end of our course or the end
It
of,
still has 3 weeks after this.
okay.
Okay, I've uploaded the clustering pending topics and the intro to NLP. So this was just an introduction. Okay, we will do all this in the implementation. We'll discuss all the details. All right, I'll stop here. We'll meet next Monday. Until then, please go through everything that we have done, if you can, because that will be the last week. Okay, so whatever queries that you may have, you can ask in the beginning or in between anytime. So, but please know that that would be the last week with me. I'll not be available afterwards. Okay, so take care and bye-bye. Enjoy your weekend.
Same
Bye.
to you, Sanatan. Thank you.
Thank you.
Bye, everyone. Yeah.